So this video will serve as a review of subnetting. This is an exercise that you should have done in a previous class. So the first thing you have to do is to count the number of networks. So here is one network, 2, 3, 4, 5, 6. So we currently have two networks, or excuse me, we currently have 6 networks. Our address that we are starting with is 200.200.3.0. It's a /24, which means that the /24 means that our subnet mask will be 255.255.255.0, which is expressed in binary is a series of 24 ones. So that's where we get that /24. Now, for us to subnet, what we're going to be doing is we're going to be working in this last octet, and we use this formula when we're deciding on how to subnet. We kind of use this from both directions, and so we'll talk about that in just a second here. So we'll borrow bits is the term that we generally use from the left side of this last octet. So we're working in this last octet. We're borrowing bits, and we're changing those from host bits into network bits. So we will borrow a certain number of bits, and then we're going to have a certain number of bits left over. So we can apply this formula both directions. So if we have a certain number of networks that we need to cover, we'll borrow the number of bits that makes that appropriate. If we have to have a certain number of hosts for each of these networks, then we have to be sure to leave enough host bits to cover those remaining hosts. So we just said that we had 6 networks, so our capital N in this situation is 6, and so we're solving for lowercase n. So it's 2 to the n minus 2 needs to be greater than or equal to capital N. So we're solving for networks again. So 2 to the n minus 2 needs to be greater than or equal to 6. So if we solve for n, and I won't do that math, I think you probably do that in your head. 2 to the 3 is 8 minus 2 equals 6. So that means that we are borrowing 3 bits that used to be host bits in the last octet. We're borrowing them and we're converting them into network bits. So our new subnet mask is actually going to look like this. So 24, 25, 26, 27. So we're going to have a /27, and that is going to leave us with 5 host bits that are still zeros here. So our range is going to be 2 to the 5th or 32. And we're using, 2 to the n. We don't do the minus 2 as far as the range. That's 2 to the number of bits left over. So there's 5 bits left over. So that's a range of 32, which means that we're going to be counting down and creating these new networks, at 0, 32, 64, 96, 128, 160, 192, 224, and then we'll also count all the way down to 255. Excuse me, we'll count down to 256 would be the next available number. Now, we're working with an octet of 8 bits, so the highest binary number that you can have is all ones, which equals 255. So now what I've done is I went in and for each of these ranges, so we started at 0, 32, 64, and so if 32 is the beginning of the new range, then 31 is the end of the previous range. If 64 is the beginning of this new range, then 63, not 65, 63 is the end of that particular range. Hopefully all these other numbers are correct. Now, this column here becomes the new network number for each of these individual networks, and this becomes the broadcast address for each of these individual networks. And it's only those that the only numbers that we can use are those that are between here. So between 32 and 63 is a set of IP addresses that we can utilize for a particular network. So we could use 33 all the way up to 62. And so if we look back at the networks that we had borrowed here, and I've messed my document up somehow. We could address this one with 33, this one with 34. You know, we could do 65, 66, 67, 68, 69, 70, and 71 here. And then let's see here, our next range would be, so we could do, you know, maybe 97, 98, etc. So for each of these networks that are here on the diagram, each of those networks that we've identified as being separate networks, each one of those is going to have, you know, a range of IP addresses that are allowable for that.